Okay, good. Can we make a start, please? So there's quite a lot to get through today. I want to try and get Poisson distribution done, as much of it done as we can. Is that okay? So let's have a quick look at this question. This is a question which I didn't manage to get onto yesterday. I said to you, go away and do it as homework. But actually looking back, like I went away yesterday and had another look at it, and I thought, actually that's quite a good question which we want to go through. Because it's quite sort of, it ties together some of the stuff that we've already looked at before. Okay? So let's have a think. Let's have a think. Okay? We've got Eric and Ross, and they're throwing skimming stones. Now, if you don't know what a skimming stone is, effectively, if you go to the beach, you get these kind of flat stones sometimes, and you can kind of skim them across the waves. Okay? The probability that a stone thrown by Eric will hop is 0.2. So basically, we can start to think of this as a binomial distribution, right? You throw the stone across the wave, and it either hops or it doesn't hop, okay? So that sounds like a success or a failure, right? And you've got a probability of that success, yeah? Which is 0.2, right? Whereas for Ross, the probability is 0.1. Does that make sense? Okay. Now, both boys throw 10 skimming stones each. So you've got built in there a number of trials. You've got an n, okay? So here's how I would set this up, okay? I would say, in fact, let's call it E and R for Eric and Ross. You can call the letter anything you like. So I'm going to define my random variable. So I'm going to say E, comma R, so Eric and Ross, okay, are random variables, okay? And they correspond to the number the number of skimming stones that hop. Okay, so they both throw 10 skimming stones each, okay? And these random variables, E for Eric and R for Ross, corresponds to the number of skimming stones that will hop. So I define my random variable first. By the way, it's totally fine to define it like that if you wanted to define them separately. So E is the number of skimming stones that will hop for Eric, and R is the number of skimming stones that will hop for Ross. That is fine as well, okay? But always define your random variable in, well, any time you answer a question like this, okay? Now, have a look. Eric is going to be binomially distributed. So E is going to be binomially distributed. You remember that notation from yesterday? What is n? What's the number that goes first? What's my parameter? 10. Perfect. And what goes here? 0.2. It's the probability of success. In this case, my success is a skimming stone that hops. Okay? And the same thing for R. So R is going to be binomially distributed. What goes there? 10. And what goes there? 0.1. So these are my parameters for each of these two random variables. Does that make sense? So I'm literally laying out, if you got this question in exam, I'm literally laying it out how you should also look to lay it out in an exam situation. Okay? Right, so part A. We need to determine the expectation and variance for Eric. So we need to find E of Eric, okay? And you need to find the variance for Eric, okay? So how do we calculate the expectation of a binomial distribution? Can anybody remember? Plus times, perfect, yeah? So it's n times by the corresponding probabilities, okay? Yeah? Remember that formula is in the formula booklet as well, so you don't need to remember it. Okay, good. So you've got Eric, okay? What's your n? 10, perfect. And what's your probability of success? 0.2. So what's your expectation? 2. So basically, if Eric does this 10 times, you expect 2 of those 10 skimming stones to be successful. They will hop. Is that okay? Okay, and what's the variance? How do you calculate the variance? Exactly. So you times n, which is 10, times by the probability of success, which is 0.2, times by q. What's q again? 0.8. Yeah, 0.8. It's 1 minus p. Yeah? So it'd be times by 0.8. So what do we get if we do that? 1.6. Perfect. Okay. Okay, let's just very quickly do the same thing for Ross. Okay, so what's the expectation for Ross? How do you calculate it? 1. Good, it's 10 times 0.1, right? And what's the variance for Ross? 0.9. Good, so it's 10 times by 0.1 times by 0.9, which comes out as 0.9. Ooh, 0.9. Okay? Then have a look at part C. We want to find the combined expectation and variance for the two boys. Okay? So in other words, what we want to find is the expectation of Eric plus Ross, and we want to find the variance of Eric plus Ross. Okay? Now this ties back together the formulas which we looked at before when we were looking at expectation and variance algebra, right? So for example, if I asked you to say, what is the expectation of x plus y? What is that equal to? Can anybody remember? Perfect. The expectation of x plus the expectation of y. So come back down here. If we want to find the expectation of Eric and Ross, so Eric plus Ross, that will just be the expectation of Eric, which is 2, plus the expectation of Ross, which is 1. So the expectation of the two boys put together should be 3. Is that okay? Yeah? Okay, what about variance? So if I ask you for the variance of x plus y, what's this equal to? Yeah, go on. Variance of x plus the variance of y. Is there anything else? Good. 2 times the covariance of x and y. Now, in this case, so this is the true formula. This is the true formula. But this only holds providing those two variables are what? X and y are dependent, right? So you have a covariance if they depend on each other. If you like, covariance is a measure of how well related those two variables are. Okay? So if they're dependent, you have a covariance term. Whereas if they're independent, in other words, if one variable doesn't affect the other variable, then you don't have this covariance term. Now have a think. Are these two boys independent of each other? So if Eric throws skimming stones and Ross throws skimming stones, are those two things independent of each other? Yeah, absolutely. Like the chances of a skimming stone hopping for Eric does not affect the chance of a skimming stone hopping for Ross. Does that make sense? So therefore it should just be the variance of Eric plus the variance of Ross. Is that okay? So the variance of Eric is going to be 1.6. The variance of Ross is 0.9. You add those two things together, what do you get? 2.5. Is that okay? Any questions about that?